Augmented reality, AR, and virtual reality, VR, are reshaping how we interact with the digital world, but they do it in very different ways. AR overlays digital elements onto our real environment, while VR immerses us in a completely virtual space. From gaming and education to healthcare and retail, both are making big waves. But which one will dominate the future? In this deep dive, we'll explore their key differences, real-world uses, and what experts predict about the ultimate winner in the AR versus VR battle. Today we will talk about augmented reality versus virtual reality. Which will win? So before we start, make sure to hit the like button and subscribe to my channel. 1. Defining AR and VR. Augmented reality, AR, and virtual reality, VR, are often used interchangeably, but they are fundamentally different technologies. AR overlays digital content onto the real world using devices like smartphones, tablets, or AR glasses. It enhances reality by integrating digital elements such as 3D objects, text, or animations. On the other hand, VR creates an entirely digital environment that immerses users through headsets like the MetaQuest or HTC Vive, cutting them off from the physical world. AR is additive, building on what exists, while VR is immersive, replacing reality altogether. Each technology has unique applications and implications, with AR being more mobile and interactive with the real world, and VR offering total escapism ideal for simulations, gaming, and training. Understanding this foundational difference is key to evaluating which technology may dominate in the future landscape of human-computer interaction. 2. Hardware evolution. The evolution of hardware for AR and VR plays a crucial role in adoption. VR headsets have become more affordable and powerful, with devices like PlayStation VR 2 and MetaQuest 3 offering wireless experiences with impressive fidelity. These headsets often include motion controllers, eye tracking, and spatial audio. In contrast, AR relies on less bulky hardware, ranging from smartphones to smart glasses like Microsoft HoloLens and Apple Vision Pro. While AR glasses are still relatively expensive and bulky, they're evolving fast, integrating LiDAR sensors, hand tracking, and lightweight optics. However, AR's dependence on external environments means it must process real-time data more efficiently, demanding greater computing power in smaller frames. Battery life, display resolution, field of view, and comfort are challenges both face. The hardware war isn't just about performance, it's also about accessibility. VR is ahead in immersive experiences today, but AR holds more promise for everyday integration through compact, wearable devices. 3. Use case dominance. The battle for technological supremacy hinges on practical use cases. VR excels in entertainment, gaming, and immersive training simulations. It's widely used in gaming, like Beat Saber, Half-Life, Alex, therapy and education, medical, military, flight. Its strength lies in full sensory immersion, making it ideal for scenarios requiring deep focus and virtual presence. AR, on the other hand, is winning in productivity, retail, navigation, and manufacturing. For example, IKEA's AR app lets users visualize furniture at home. AR is also used in automotive heads-up displays, medical imaging overlays during surgeries, and AR-guided assembly in factories. In education, AR brings interactive textbooks to life. Businesses use AR for real-time data visualization and training without disconnecting from reality. Because AR complements the real world, it has broader utility in daily life. While VR may dominate in niche immersive experiences, AR's potential for widespread, real-world integration gives it a critical edge in practical applications. 4. Market trends and investment. Market research indicates that AR is projected to outpace VR in terms of global market value by the end of this decade. According to Statista and Galaxy, the global AR market is expected to surpass $100 billion by 2028, compared to $60 billion for VR. Major tech companies are betting heavily on AR. Apple's Vision Pro emphasizes spatial computing rather than just immersive VR. Google, Meta, and Microsoft have invested in AR through smart glasses, AirCore, and HoloLens, respectively. While Meta's VR investment is enormous, over $10 billion in the metaverse alone, its Horizon Worlds VR platform has seen mixed success. In contrast, AR investments are more evenly distributed across industries, from healthcare to retail. 5. User accessibility. Accessibility is a decisive factor in determining the future winner. AR, available on devices millions already own, smartphones and tablets, offers low entry barriers. Users can access AR through mobile apps like Snapchat Filters, Google Lens, or Pokemon Geo. This mainstream reach makes AR adoption faster and less costly. In contrast, VR requires specialized headsets, space, and often tethered or standalone systems. These barriers make VR less accessible for casual users or those with limited space or resources. Moreover, VR can cause motion sickness in some users, limiting long-term usability. AR is less likely to induce discomfort since it doesn't disconnect users from their surroundings. For education, tourism, shopping, and remote assistance, AR can be adopted without additional infrastructure. 6. Future tech integration. Looking ahead, AR and VR will both play significant roles in shaping the future of tech, especially within the metaverse, artificial intelligence, and AI ecosystems. AR is particularly suited for smart city applications, real-time information overlays, and enhanced human-computer interaction via gesture or voice. Imagine walking through a city with AR glasses that translate signs, show directions, or identify people. In healthcare, AR can assist in diagnostics and surgeries using AI to overlay data in real time. VR, meanwhile, is key for developing fully immersive digital worlds, like virtual offices, classrooms, or therapy environments. As 5G and edge computing become widespread, both technologies will benefit from faster, more stable connections. However, AR's ability to enhance rather than replace reality allows it to work synergistically with other technologies. 7. Consumer behavior and adoption. Consumer behavior is leaning towards seamless, non-intrusive tech that improves convenience and productivity without significant disruption. This favors AR over VR. Most consumers prefer tools that enhance their existing routines rather than create entirely new ones. AR apps already support shopping, trying on clothes or makeup virtually, education, anatomy overlays, and even live sports, real-time stats through AR glasses. VR requires users to isolate themselves, which is less appealing for casual, everyday tasks. Social media platforms are also rapidly integrating AR features for filters, avatars, and real-time effects. Consumers interact with AR almost unknowingly, which accelerates adoption. By contrast, VR is still viewed more as an entertainment or niche tool. Even in gaming, where VR has made the most impact, it's yet to become a household staple. 8. The final verdict. Both AR and VR have transformative potential, but their trajectories are diverging. VR shines in immersive entertainment, training, and virtual collaboration, offering depth and presence like no other tech. It's ideal for controlled environments and dedicated use cases. However, AR's adaptability, ease of access, and real-world integration give it the upper hand in everyday utility, business applications, and long-term market scalability. The future isn't necessarily a zero-sum game. AR and VR may coexist, each dominating their own domains. Still, if the measured is mass adoption, real-world integration, and commercial versatility, AR seems more likely to win in the broader sense. It's poised to redefine how we interact with the physical world, enhancing reality instead of replacing it. If you like this video and would like to see more like it, please give it the thumbs up. Leave a comment and click the button to subscribe.